Let's look at an example of a percent yield type stoichiometry question. Percent yield, as you recall, is equal to the actual yield divided by the theoretical yield times 100, then add a percent sign. The theoretical yield is what we calculate on paper. This is what we do when we solve a stoichiometry problem. The actual yield, on the other hand, is measured in the lab. It's what you actually produce when you do the chemical reaction. So let's look at how a problem might be phrased. When 45.8 grams of potassium carbonate react with excess hydrochloric acid, 46.3 grams of potassium chloride are formed. Calculate the theoretical and percent yields of potassium chloride. To begin with, we're reacting potassium carbonate and hydrochloric acid. We have two compounds, potassium carbonate and hydrochloric acid. This will be a double replacement reaction where the potassium and the hydrogen switch places. So the potassium ends up with the chloride and the hydrogen ends up with the carbonate, giving me KCl plus H2CO3. Carbonic acid, the H2CO3 that is formed, will rapidly dissociate into water and carbon dioxide, and those are the driving forces for this reaction to occur. That is the formation of water and a gas, carbon dioxide. Before we can actually do any stoichiometry on this, we need to have a balanced chemical equation. So as we look over the equation, we notice we have two potassiums on the reactant side and only one on the product side. So we must add a coefficient 2 in front of the potassium chloride. That then gives us two chlorines on the product side. We have only one on the reactant side, so we need to add a coefficient 2 there. Now that we have the balanced chemical equation, I'm going to put the information from the question under the equation. We're told that we have 45.8 grams of potassium carbonate reacting with excess hydrochloric acid. Anything that is excess we can ignore or X out and forget about from this point forward on this question. Now we're told that we are going to form 46.3 grams of potassium chloride. That is not a theoretical yield, that is the actual yield. So I'm going to write that above my equation. 46.3 grams again was what was found in the lab. That's called the actual yield. So what we need to do next is calculate how much we would have expected to get for this problem. That is figuring out how many grams of potassium chloride we would expect if we start with 45.8 grams of potassium carbonate. This is called the theoretical yield. It's a regular stoichiometry problem that we've done many times before. So we'll set it up. What are we looking for? X grams of KCl equal to 45.8 grams of potassium carbonate, what we're given. Because we have grams of potassium carbonate, we need to convert that to moles. So I will have to calculate the molar mass of potassium carbonate. I have two potassiums, each that weigh 39 grams per mole. I have one carbon that weighs 12 grams per mole, and I have three oxygens, each that weigh 16 grams per mole. Adding this all up, I find the molar mass of potassium carbonate is 138 grams per 1 mole. The grams of potassium carbonate cancel. If I were to stop now, I would have an answer in moles of potassium carbonate, and I want it to be in grams of potassium chloride. But once I get to moles, I can use the coefficients from the balanced chemical equation to change from one substance to the other. Notice that the equation suggests 1 mole of potassium carbonate will produce 2 moles of potassium chloride. So I'm going to substitute that in. Because I have moles of potassium carbonate on the numerator, it's going to fit on the denominator. So again, from the equation, 1 mole of potassium carbonate is going to go right down here, and that will produce 2 moles of potassium chloride. That will go right up here. The moles of potassium carbonate cancel, leaving me with moles of potassium chloride. I'm interested in grams of potassium chloride, so I need to do one more conversion. I have to calculate what 1 mole of potassium chloride weighs. So 1 mole of potassium chloride, recall potassium is 39 grams per mole, chlorine is 35.5 grams per mole. Adding that up, I get 74.5 grams of potassium chloride per mole. moles of potassium chloride will cancel. At this point, I just have to calculate this, taking 45.8 grams times 1 times 2 times 74.5, divide by 138, and that will equal 49.4 grams of potassium chloride. This number, the 49.4 grams of potassium chloride, is my theoretical yield. So I've answered the question, calculate the theoretical yield. Now I just need to calculate the percent yield. And as you recall from the previous slide, percent yield is equal to actual yield divided by the theoretical yield. So I'm going to plug in some numbers here. The actual yield was 46.3 grams. So we'll put that into here. And the theoretical yield was 49.4 grams. That goes down here. And we solve this on our calculator, and we find out that the chemistry of this reaction is 93.7% efficient.